Hello, my name is Mark Costales, and in this presentation, I will discuss what are the applications of 3D graphics and what is the role of mathematics in graphics. 3D graphics are everywhere in digital media, from movies and games to web design and virtual reality. But what are the main uses and benefits of 3D graphics for different types of media? And what are the challenges and opportunities for 3D artists and developers? In my presentation, we will explore some of the most popular applications of 3D graphics for digital media and how they create immersive and engaging experiences for audiences. Number 1. Animation and visual effects. One of the most obvious and well-known applications of 3D graphics is in animation and visual effects, or VFX. It is used for movies, TV shows, commercials, and other video content. 3D graphics allow animators to create realistic and fantastical characters, environments, and phenomena that would be impossible or too costly to film in real life. 3D graphics also enable more creative and expressive storytelling, as well as seamless integration with live action footage. Some examples of 3D animation and VFX include Pixar films, Marvel movies, and the Lion King remake. Number 2, video games. Another major application of 3D graphics is in video games, which have evolved from 2D sprites and polygons to complex and detailed 3D worlds and characters. 3D graphics enhance the gameplay and the aesthetics of video games, making them more immersive, interactive, and dynamic. Some examples of 3D video games include Grand Theft Auto, Fortnite, and The Last of Us. Number 3, web design. A less obvious but increasingly important application of 3D graphics is in web design, which refers to the visual and functional aspects of websites and web applications. 3D graphics can improve the user experience and the user interface of web design, making it more attractive, engaging, and intuitive. 3D graphics can also add interactivity and animation to web design, as well as showcase products and services in a more realistic and appealing way. Some examples of 3D web design include Google Earth, SketchLab, and Shopify. Number 4, virtual reality or VR. A relatively new but rapidly growing application of 3D graphics is in virtual reality or VR. It refers to the simulation of a 3D environment that users can explore and interact using special devices such as headsets and controllers. Some examples of 3D VR include Beat Saber, Google Expeditions, and VR Chat. Number 5, augmented reality or AR. A related but distinct application of 3D graphics is in augmented reality or AR, which refers to the overlay of 3D objects or information onto the real world using devices such as smartphones and glasses. 3D graphics can also enable various applications of AR, such as navigation, gaming, shopping, and art. Some examples of 3D AR include Pokemon Go, IKEA Palace, and snapshot filters. And finally, 3D printing. A final but emerging application of 3D graphics is in 3D printing, which refers to the process of creating physical objects from digital models using device that deposits layers of material. 3D graphics can enable the design and the customization of 3D objects, as well as the visualization and the verification of the printing process. Some examples of 3D printing include Lego bricks, prosthetics, and organs. So in this part, I will discuss what is the role of mathematics in graphics. Mathematics plays a crucial role in computer graphics, as it provides the foundation for the creation, manipulation, and rendering of digital images and 3D models. Here are some key ways in which mathematics is used in computer graphics. Number 1, Geometry and transformations. Vectors and matrices are used to represent and transform 2D and 3D geometric shapes such as points, lines, planes, and objects. Transformations like translation, rotation, scaling, and shearing are essential for positioning, orienting, and resizing objects in a virtual scene. Number 2, rendering and lighting. Equations from linear algebra, calculus, and physics are used to simulate the behavior of light, including reflection, refraction, and absorption, to create realistic lighting and shading effects. Techniques like ray tracing and rasterization rely on mathematical algorithms to determine the color and appearance of each pixel in an image. Number 3, curve and surface representation. Mathematical functions such as splines and Bezier curves are used to represent smooth, continuous shapes and surfaces, which are essential for modeling organic objects and creating smooth animations. Number 4, texture mapping. Coordinate systems and mathematical transformations are used to map 2D textures onto 3D surfaces, creating the illusion of detail and realism. Number 5, animation and simulation. Differential equations and numerical integration methods are used to simulate the motion and behavior of objects, such as rigid bodies, fluids, and deformable materials for realistic animation and special effects. Number 6, image processing. Techniques like filtering, convolution, and Fourier analysis are used to manipulate and enhance digital images, such as for image compression, edge detection, and image enhancement. And lastly, number 7, computer vision. Mathematical algorithms, such as those used in linear algebra, optimization, and machine learning, are employed in computer vision tasks such as object recognition, tracking, and 3D reconstruction.